Hello, Jack.
Hello there.
Jack, you're looking good.
Thank you. Thank you. Would you believe somebody complimented Brian's background?
Yes.
Would you believe that's an N scale?
Oh, I didn't see
Really?
it.
An N scale scene?
Yes, yes, we are now.
Yeah, that's it.
Nice.
That's Springfield, Oregon on my layout. I decided to play with the backgrounds. All right, let me introduce the program now that we're recording. All right, so show and tell this morning will be by John Gornick. He's going to show us a lighting project, LED light strips on his layout and his adventure thereof. And followed by that, we're going to have a layout tour by Dick Trotter, Coyote Pass and Northern Railroad. And then finally, we'll get part 2 of Tim Foote's electronic clinic. So without any further ado, let me introduce John. He's from the Cajon division. So let me set you up here, John, with a spotlight, and we'll go.
Okay, we're ready to go?
Ready to go.
All right. Let's see, got to hit share and then we're in business. Okay, can everybody see the PowerPoint?
Yes.
Yes.
Okay, so I thought, first of all, if you hear a funny accent, it's because I grew up in northern Minnesota and that's where the layout is also built. I'm actually probably more Canadian than American, but that's
Yeah, you betcha.
You betcha, exactly. I got to go to the sauna.
Okay.
My layout is in a spare bedroom. I'll just give you a little overview, and it's about a 10 by 10 layout, double decked around the wall. If my son ever decides to move back home, he's pretty much screwed, but it is what it is. Bench work is 1 by 3s, except for a helix, which is 1 by 4s. I don't know if you remember, a couple of months ago, I did a helix presentation. And what basically happened is I needed an easy way to light both the decks, and I didn't want to monkey with too much wiring, and I want to make it easy to install. So after doing some research, I decided that LED strip lights were going to work because they're cheap, and I'm cheap, and they're easy to install. At least I thought they were easy to install. What I've got here is a list of where I bought everything. I sent Ryan this PowerPoint, so if anybody wants it, just contact him or me, and I'll get it out to you. But this is just where I bought it. It was eBay and Amazon, really. And then most of these power supplies come without power cords. So in my case, I was in IT for 40 years, so I've got about 30 old laptop power supplies laying around. That's where I got my power cords, but you can buy them. And then the saving grace on this project turned out to be Home Depot and 3/4 inch aluminum angle. And here's just what, the LEDs come in a 5-meter roll, at least the ones I bought. I bought bright white, and there's 60 LEDs per meter. So the light's pretty good. And then a simple power supply, looks like a computer power supply, but it's customized a little bit on the back end for easy LED hookup. And here's a close-up of that lookout. The black and white wires on the left side of the screen are going to a terminal strip that goes to the lighting bus. And then that's just the power cord on the right side that comes in. You see, I basically had to cut the cord and strip the wire a little bit, but it was a pretty easy hookup. So far, so good. Here's what the LEDs look like when they come. As I said, they come in a 5-meter roll. You can buy them longer, but I bought 5 meters. And about every, I forget what it is, about every foot or so, maybe it's 18 inches, they have the little scissors mark where you can cut them. So you can custom make the length, and then those little, you've got little soldering pads, so you can wire them in however you need to. And let me tell you, that's a real joy the first time you try to do that. But once you get the hang of it, it's fairly easy. And this is what it looks like, where it's connected between 2 different strips, all wired in. The first problem I ran across was, how am I going to hang these things? So I was just going to hang them off of the underside of the bench work for the lower level. And then I have some upper level bench work, or if you want to call it that, where the valance is going to hang off of. And I thought I would just hang it off of that. So everything was going along just swimmingly until I found out that the LEDs themselves are very cool, but they're extremely inefficient. So they actually run real hot. If you're pumping 100 watts down that line and they're 30–40% efficient, somewhere between 60 and 70 watts comes out in heat. So enter the aluminum angle. I wasn't sure what I was going to do. I was wandering around Home Depot because that's, as my daughter says, that's my hobby. And it basically became a built-in heat sink for the LED strips. It made it really easy to mount them. And they actually help direct the light. It's just 3/4 inch aluminum angle, real easy to put up. These LEDs have the back side of them is like peel off tape. So now I could just peel that tape off, stick them on the aluminum, and it's hung. It was turned out to be a brilliant decision by the general manager of this layout. But it was a struggle to try and figure out how I was going to get rid of that heat, and the aluminum angle does a great job with it. So, and this is what it looks like. It's just I'm not a photographer, and I'm also not a painter. My daughter came home and looked at my clouds one day and said, it looks like a dead whale. So I guess I'm going to have to work on that a little bit. But you can see the aluminum hung here, pretty simple to mount on your bench work. And then above the helix is going to be the focal point of the whole layout. It's an iron ore mine in the town I grew up in. And you can see how I ran the aluminum angle all over to light this area properly. Not all the bench work is even in yet up there, but that's basically what this is a shot of. And now you can see it with it turned on. You can see the wiring going out to the lighting bus here running down the middle. But this is what it looks like once you have the strip lights tied up to the aluminum. And it turned out to be a fairly basic project once I got a couple problems taken care of. And then this is just a top view going down the upper, the valance will be on the front of this, but that's the lighting bus running down the top of the layout. And, because I'm detailed, here's my terminal strip where I tie in the feed from the power supply to a couple of different buses going out to either side of the layout. You have a positive and a negative side, which is important when working with these LEDs. You got to make sure you get positive to positive and negative to negative. Otherwise, things get exciting. Then my second problem. So I installed the lower level of the lights. Everything worked great. I thought I was a genius. I put the upper level in. It worked great for about 2 minutes, and then the power supply blew out. So after swearing at cheap Chinese manufacturing techniques for about an hour, I got another power supply, and it came in. And it lasted about 2 minutes, and it blew out. And then I realized that the cheap Chinese manufacturing was really my brain, and I had to do a little bit more research. And what I found out is the power draw for these LEDs is about 0.2 of a watt. So for every meter, I'm drawing about 12 watts of power. I had 32 meters total of lighting. So I needed about 380 watts. My power supply was rated at 260 watts, hence the problem. Solved it pretty easily, 2 power supplies. So, and these power supplies, fortunately, they're not real expensive because I went through 4 of them till I figured this out. And this is what it looks not like now. So you can see the bus wires coming in and then 2 power cords. Sits in there. Fans kick on when they're supposed to. It actually works really, really well. I've been pretty happy with it once I got past a couple of the issues there. And you can see I'm not a good photographer. I'm taking this with an iPhone, but you can see the difference between dark and when I light it up a little bit. So it's actually been, it's a joy to work with it. I'm handling track, so it's nice to have all that light when I'm trying to do that. And I don't know, the LEDs with the pictures, I'm going to have to learn how to take better pictures. I guess that's something I've never done. And because when you're in person, the colors and everything look perfect, but with the picture, it just doesn't work. But I don't know jack about photography, so I'll have to figure that out sometimes. And you can see here where it looks a little better, where I've got a bigger area lit. So it actually does a pretty nice job of lighting the layout. You can see here on the left, that's the top of the helix coming up. So that's about it. I mean, if anybody has questions or wants to see it or wants to talk to me or whatever, just feel free to contact me and we can arrange something. I'm generally around. I'm retired, so I play golf 3 days a week and play trains the rest of the time. So anyway, that's it for me. Thanks for your time. Thanks for having me.
Thank you.
Thanks.
I have a comment. This is Bob Beam.
Mhm.
I do a lot of underwiring also. There is a jumper that's made that fits on the end of the string,
Yeah.
and they make them in in a 2-contact and a 4-contact.
Oh, yeah.
And it helps you. You can splice them to whatever size. It's much easier to just slide these on, clip this down, and it will hold in place.
Well, where the hell were you about 2 months ago, Tim?
I was right here.
Yeah, no, I should have done that. Boy, that would have saved a lot of time, because that soldering, you can get good at it, but what a pain in the neck.
Yeah.
Okay, thanks.
Tim, where do you buy those at?
Well, when I picked up the lights, they actually were part of the package. It was an optional part. I don't have the number on it. I can look it up and repost it for you guys.
Yeah, that'd be awesome. Thanks.
Because
Yeah, that's good.
each strip has a different connector, so you have to make sure you get the right junction for the right strip.
That's me being cheap, though, trying to find the cheapest thing possible, so I don't have any accessories. And the other thing I'm kicking myself about is I ran just white. I should have run multicolored, which would make it easier if I ever wanted to go to nighttime operations. So I'm going to have to, at some point, I mean, the layout, I got so much work to do. That's the least of my worries. But at some point, I'm going to probably have to modify that.
I've found the multicolored strips are not true color. They're really hard. When you go in and you've got like, I think it's 12 colors that you can choose from, they don't really give a true color. You have to use the RGBW, and a lot of them are RGB A for amber. So you have to make sure you pick up the one that has the white in it, and that gives you a better transition from daylight to nightlight.
That's good to know. I may be contacting you, Tim, if I ever get to that project. So
That's Robert.
I'm sorry, Robert. I don't know where never mind.
All right, I'm talking with the mute button on. Anybody else got anything for John before we move on? All right. Thank you, John.
Oh, you're welcome.
That was really interesting. Thank you.
Yes.
You're more than welcome. It was fun.
Okay, I'm going to introduce our next up. So this is going to be Dick Trotter. Dick is here in San Diego, and he has a great layout to show. And so Roger and him are going to be working together on this. So you guys ready?
Yes.
Yeah, I'm good here.
Okay, I just have to find you. I'm going to spotlight you. Okay, there you go. All right. So when you're ready, Roger.
You've got me disabled.
Oh, would you like a cane? Let's see here. I'm sorry, Roger. I thought I did that.
Are we ready now?
No.
Oh.
I
Take a number.
I was going to change his name, but that wasn't going to help him do that. So here we go. Now I got the right one. All right, go ahead.
Let's have, there we go. All righty.
All right.
Looks good. Yeah, we can see it.
Okay. Well, it's
Good afternoon, everybody. This has been fun. It's almost like model railroading. Whatever can go wrong will go wrong. Anyway, my name is Dick Trotter. Thanks for joining me, and hope you enjoy my presentation of the Coyote Pass and Northern. Roger's got control of the next button, so I think let's go ahead and do next. This is a schematic of the railroad. And, oh, okay, I do have this. The railroad starts in a fiddle yard. I have a fiddle yard on one end of the railroad that has 4 terminals. And that gives me the ability to route 4 different trains. They cross each other and they go to different parts of the layout. And so if you were to follow a train from Murtaugh, which is on the blue line, then what you'll see that it leaves, comes out around, and it goes through Purgatory, which is this upper level to the left, comes around, some of it ducks under, and if you follow it around, you'll eventually come back into Tucson. That is one route. The other route being Santa Fe to Yuma. So because of the overlap, I started out with red tape, and at a point I went into in the lower connection, I went to the white tape because the red would cross over itself, kind of got lost in it. But the building that it's in is visually is split along the center line between Brunswick, Purgatory, and Rocky Point. So there's actually a wall there. So it's set up in 2 rooms, and if you're in one room, you really don't have a lot of sight into the other. So let's go on to the next picture. This is an overview of the fiddle yard. In the middle, there is enough track to set up about 6 to 7 trains at a time. We usually set up about 5. And above the fiddle yard is one of the towns that we switch. That is Bentonville, and it's accessed from the left-hand side bridge. Go ahead, next. This is the end of the fiddle yard, showing the controls for turnouts down at the lower part of the board. And then the numbers are the numbers of the trains. And also in the lettering for Tucson, Murtaugh, Santa Fe, so forth, are the beginning or the end of a train. Train starting in Tucson will end in a different town, so forth and so on. You start in one town, you end in another. And takes, on a straight run, takes about maybe 15 minutes to get around the railroad. We do not do continuous running. It's all point to point. Next. Another view of the fiddle yard and a view of the Bentonville, the switching area just above it. To the right, you'll see clipboards with white paper on them. That's our train orders. I make those up in advance so everybody can just walk in, pick up a clipboard, and start running trains. No big deal. Next. Another view of the fiddle yard. Colton Freight and Transfer, Basham Milling. This is what those buildings are on another route that is not, it's attached to the fiddle yard, but not part of the fiddle yard. Next. And again, this is above the fiddle yard. Go ahead. Basham Milling is a cornerstone building. We built the front end. It's one of the narrow buildings they use for backdrops. The side you're looking at is actually a photograph that has been manipulated on Photoshop. So what looks like 3 dimensions is really flat. Next. Same thing here. This is another Walters building that is a backdrop building. So it's only about 3 inches wide. They are not built with backsides. So again, we took a photograph of the front, did a little bit of massaging on Photoshop, and we got a backside to work with. Again, a flat surface. Next.
You want to tell them about this hole?
Oh, the hole. That was a joke. You know, what's on the other side of that is a munitions company. And that the joke was somebody got carried away with munitions loadings on the bottom side and blew out a hole in the back of the building. A little bit of humor never helps, never hurts either. And this is the end of the fiddle yard. As it starts around to the right, it's going in. It will be going into our first town. Next. Top of the fiddle. This is part of the branch from the town of Desert Wells. The top of this is at the present time, it's a grain elevator. I have the ability to take that structure out and replace it with a set of coal mine setup, and the bases are just interchangeable. I was a little further along. I've got a picture of what I've done in a very similar situation in another part of the railroad. Next. The end of that scene. The road is below. You can see the track running up the backside, and that leads up. One leads up to Summit. The other one leads up to that switching area, and you can see the start end of Desert Wells at the bottom. Next. Another shot, same area. What's on the right is a nice house and a propane dealer. Next. There's another shot of the ice house. I'm doing some of my own background painting this time. Originally, all my backdrops were hand painted by my good friend Glenn Shimada. But we had to rebuild part of the railroad about 1.5 years ago, and because of COVID, he hasn't been coming around too much. So I kind of got tired of blue walls and started smashing paint up there myself. So I'm not the artist he is, but it's not too bad. I'm getting there. Next.
Looks good from here, Dick.
Say again.
Looks good from here.
Well, I look at it as they're acceptable. When you're operating the trains, you have a tendency to concentrate on the paperwork, what you're doing, rather than actually looking at the background. So it's kind of like icing on a cake. The cake is good, the icing is okay. Next.
Yeah, this is he.
This is, again, we're just stepping along the town of Desert Wells. Go ahead, Roger. This is another
No.
kit bash. That's part of Walter's.
Right.
Say again? No, this is another kit bash.
Thank you.
It's a.
Yeah, I don't know.
Okay, go ahead.
I think we're picking up somebody else's communication.
Somebody's
Continue.
unmuted.
Continue. Yeah.
Next. Oh, I did it.
No, you're fine. You're fine. You're fine.
Oh, okay, I didn't do it. Roger, click it.
You're to the next one. You want to talk?
There we go, okay. Chemical plant, it's part of part of Desert Wells. Each town has about someplace between 12 and 17 car spots. So we get a lot of switching variations. Next. Again, overview, a little bit of the town here, and towards the right end, you'll see the tunnel. That's the underneath running to the next part of the railroad. Same thing, town. Got some cars, got some people. Go ahead and move it on. That's the same shot from a different angle. Again, I use a lot of buildings from Walters, DPM, very little scratch built. Not my bag. I'd rather a kit bash or build pretty much what's available out there. Go ahead. Stockyard, that I built. I put the clear plastic in the front so we didn't stick our elbows in it. And it's fairly narrow, so right now there's not too many cows there. Next. And that's the end of Desert Wells. What you see above, it says Summit, that is a town, and that's on another route. We'll get back to that one later. Next. Oh, that's a tunnel, and that's going underneath Summit. When you leave Desert Wells, you actually go underneath Summit. It turns to the right and goes along the far wall. Past this area. This area is, the upper track is the lead into Summit. The lower track is the lead out of Desert Wells. Prior to our last adjustment, this area was only about 2.5 feet long. We had to move a lot of building, the physical building we're in. And this area, when it was rebuilt, became about 6 or 7 feet long in there. I needed the holes to access the track underneath. So once we got them cut, I didn't particularly care for the way the finish was. So I found the stripping that I put around the holes. Once I got that done, I said, hey, it looks like the windows out of a passenger car. So that's what we call that area. It's called windows. And to the right, it goes into the lower track, goes into the next town, which is actually Coyote Pass. Roger. Same shot. Signs. Most of on the older part of the railroad, we had signs above the town. The sign in the middle, which is kind of tan, it would indicate the town that you're actually in. The whiter sign on either side would be the next town you're going to or the town you're coming from, depending on your direction. Roger. This is the start of Coyote Pass, a supply company, small supply company. Kit was built by a friend of mine. Also the framed out building in the back, he's a carpenter. So he built that based on the type of work he did. And that building has been like that for about 20 years. Those guys are really slow workers. Next. Another shot, same building, has 2 sidings. This is the tail end of the coal mine in Coyote Pass. I have enough room for 3 to 4 hopper cars, and there's a little bit of enough tail on the track to put a box car and an occasional tank car in there. Somebody digging. This is the other end of the coal mine. It was built as a kit bash based on an article, I believe it was in Model Railroad or RMC quite a few years ago. Liked it, so I built it. Next. This is one of the key scenes on the railroad. Again, the backdrop was painted by my friend Gren Samata. The ridge built by one of my other operators, Roger O'Connell. And he built that, again, that part is about a 25-year-old structure. Next.
You can tell them about this scene here.
Oh, okay. That's the chain gang. Woodland Scenics did a chain gang stripe. And so I thought, hey, that was kind of cute. So I put that together. I got a couple of guards and 4 guys working a road job, just like they used to do in the South a long time ago. Next. What you see on the left corner is the left lower corner is the drop bridges. Now that area just the tracks cross the doorway into the train room. And rather than make a lift out, I hinged them so that they hinge down. They each have, there's 2 bridges, one above the other. And each bridge has a micro switch attached to it. You can see it at the upper corner of that upper bridge. so that when the bridges are down, it breaks the electrical connection to about 4.5 feet of railroad on either side of the bridge. That saves us from accidentally running locomotives off the open bridge. You could back a train up, but cars are not near as expensive as locomotives. If there's any questions while we're going, you guys kind of jump in there. I'm just rattling on here. This is the town of Sealy. I don't think I built but maybe 1 or 2 structures in this whole town. I did build the overpass, but this whole town was built by a friend of mine. Go ahead. There you go. Another shot of it. You can start to see in the background, in the far background, the buildings. Those are all photographs taken by Glenn Shimada. And a lot of we were practicing with finding the right mix of photographs of models and photographs of the real world, trying to get something that blended together. So about half of what you see is in the backdrop is photographs of the real world. And the other half are photographs of models. Some of the photographs have been altered on Photoshop to give us some variations. Next, the gray building and the brick building are 3-dimensional. The tan building next to the elevated is a photograph, as is everything behind that. That's almost the end of Sealy. And yeah, same thing. End of Sealy, and the track goes out to the right behind the building in that area. And it'll go on, the upper track comes around to the switching area. The lower track goes behind the building and it exits down lower, down, I don't know if Roger can see it exits in the corner about middle, that tunnel. What you're looking at now is the town of Clayton. And it's.
Hey, Dick, can I comment something?
Say again?
Can I make a comment?
Pardon?
Can you hear me?
My hearing is a little hard of hearing. What do you say?
He wants to say something.
Oh, go ahead.
Okay, can we go back one slide? Okay, now this is absolutely a gorgeous area. I fortunately was able to see this in person, and well, the whole layout's gorgeous. But some of the buildings on the backdrop, like Dick said, they're actually just pasted on, paper with, printed out. But some of the buildings are, I think they're made out of paper, but they have a little 3D edge to them. And then some of the buildings here are, like 1/10 of a building, and some are full buildings. And it's absolutely fantastic how that was made. But I guess I wanted to ask Dick, I said, my question would be, am I correct that you actually made little, some of your Photoshop buildings, you actually put a slight edge on each side so they became 3D. Is that correct?
Not in this shot, but in another town, yes. That's in the town of Clayton. We'll come to that in a minute. I'll point that out when we get there.
Okay, thanks.
Let me add too, this track here will emerge on the other side of the backdrop, but this track here doesn't, and Dick will explain where it went.
Yeah, that what he's pointing to now is the track, the upper track coming out of Sealy, and it goes around the backside of the railroad. It's actually above Clayton, and it's a run through. This is the tail end of Clayton. Probably one of the wider points on the railroad because the track coming up runs along the backside of the wall, makes this big U-turn and goes down to the right. to access into the town.
Explain to him where the lower track went to.
The lower track is at the tunnel that's about midway, yeah, down in that area, that tunnel entrance, that's about halfway down the photograph on the left side. That's the lower track. That actually comes out of a town that's on the further far right, which we don't see yet. The track that comes out of Sealy runs completely under the town of Clayton and does not come out for about 15 or 20 feet. This is Clayton. This is a small stockyard and processing plant. Engine facility. I used to run a lot of steam. Don't run too much steam anymore, but the coal tower, sand tower, and diesel fuel or bunker C fuel is still there. It makes for a nice switching area. This is part of the stockyard. The stock pens are behind the cars. The buildings are again kit bash from 2 or 3 different sources. Looking down through Clayton, stockyard on the left, and the engine facility on the right. Down the middle is a couple of industries on a spur. Moving, same thing. We're going down Clayton, the station. The red building to the left of to the right of the station is a canning company, and to the right of that is a team track and a couple of more industries that we can serve. What I believe what Ryan was talking about was the red buildings along about the center along the back wall. Those are photographs. And 2 of those buildings, the photograph was taken, those are photographs of models that were built for somebody else. We photographed them and we had, I didn't, but Glenn did. They were photographed at an angle. And when they were printed, we put them on cardstock, and 2 of those buildings are folded 90 degrees. So they give the appearance of 3 dimensions, but there's only 2 walls. The 2 buildings on the left, the high left, the 2 red, the one with the green sign and green front, and the one next to it are printed on paper, glued on foam core board, and there's a front side and the left side. That's the only 2 sides you see. As you move behind the track, the next set of buildings are all flat. There's no relief to them. What we were trying to do is force the perspective. So the buildings in front of the track, the yellow, the tan building is a full-size building. The photographs behind it, the photographs of models that are behind it, have been reduced in size as we progress back further. So a couple of the photographic buildings are about 90% full size. And then the ones that are flat against the wall are probably a 75 to 80% full size. And we use that reduction to force the perspective. By photographing models, we keep the visual texture that the model would give us without having the space that it takes up. This is the end of Clayton. The trees along the top edge, some are painted on the wall, some are 3 dimension. I think you can see pretty much of that. The tail end of the lumber yard, there's a small fuel facility and a team track there. Track goes around. That was Clayton. And Purgatory out of Clayton, you would be the upper track as you'd come around. This is the tunnel that comes out of Sealy. Now that track that came out of Sealy went all the way under Clayton and now comes out on the lower level into the town of Pycurus. This is the end of a a farm dealership. They've got a ramp. And this is just the start. Next, here we go. A view of that. There's the farm dealership was to the left. This is a small storage facility and supply company. To the right, about the middle, you can see the beginnings of a, there it is. There's a small coal facility for loading hoppers. Got several of those. So, next. Town of Pacuras. A lot of the town names came out of the Rand McNally Road Atlas. I just kind of went in there and picked a bunch of towns that the names sounded okay for the Southwest. Pacuras was in the Atlas, and that's the way it was spelled. Some guys say Pacuras, some guys say Pacuras. I don't have a particular choice. There's the station, water tower. There's a fuel dealer behind that. Go ahead, next. There's a local coal dealer to receive loads. You can see this big, one of the grain facilities on the upper right. And from there, it starts to go around the corner into the next room. This is another stockyard. And at the very end is a machine tool company. This is the only place on the railroad that has my name on it. And I didn't put it there, somebody else did. Next. I built the bridges. The steel bridge is part of the, I can't remember exactly who made all of that. But the lower bridge, the trestle is all wood, and I scratch built that. And there's a crossover there. One of the switches to the left is on the ground. The switch to the right is in the middle of the trestle. And that switch is operated by a rotary switch machine that's all the way underneath the railroad. And I see people are always looking, how do you get that thing to work? Well, you can't see it from this angle, but there's a small tube that runs from the switch down through the bracing and exits through the bottom, and the switch machine is actually underneath the railroad. It's about 8 inches down. Next. That's coming around your left. Clayton, it would have been around the corner on the left. We've come around the corner. This is a newer part of the railroad that had to be rebuilt when we rebuilt the building that it's in. Again, this area used to be a big U-turn, but now it's got a flat spot. This is a scene. My group and I used to go up to Tehachapi. We did that for about 25 years, going up camping. And we used to camp on this little rise right above the loop, just before you went into Tunnel 10. We did that till UP took over and they shaped everybody out. Next. This is looking down through French Crossing. It's an interchange area, sort of. There's two through lines through the area, plus sidings on either side. And the trains are set up to drop cars off and pick them up, somewhat like an industry, but their tracks look more like an interchange track than an industry. Next. Western Grain. This is where I think this one in the next picture, the next slide will show you what I did, at least part of what I did with with this grain facility. There it is. It is removable, and if you see, the white pad actually has clips on it that fit the bottom of the building, and it's screwed into the top of the benchwork. So when you put the building over the top of that white pad, everything is aligned and the tracks will go underneath the loader. I used to have a coal mine. There it is. There's a coal mine. Now the coal mine has its own base. So when I want to change, I simply take the grain facility out, unscrew the two small screws out of the base, and I put the coal mine base in the same place. And the coal mine fits right over the top of the base in the same fashion. What that does, it gives us a slightly different traffic pattern. So I go from moving coal to moving grain. What is it? The diagonal conveyor on the back side of the coal mine is painted on the wall. It's not three-dimensional. You barely see it when the grain elevator's there. You have to really look for it. Trench crossing, I put plastic up because the tracks are right on the edge of the railroad. We never dropped cars off, but we did occasionally turn around and knock them off into the railroad with our elbow. So the plastic keeps us from knocking cars off the track. Next, tracks through the tunnels, one goes to Summit, one goes to the terminal in Tucson. The bridge is the approach to the town over the top, the town of Bentonville, which is a town that's over the top of the Fiddle Yard. And that's in a rebuilt area that we had to extend because of the extension of the building. Next. Lower half of that, a new scrapyard. Used to be a welding facility. So we had a little more space. So I'm starting to build a scrapyard in there. I built the what do they call those things? Crushers. Anyway, some of that's built. Some of it's just the kits. Yeah, shredders. That's what they call. That's what I couldn't get the word. I just kind of scratched that from pictures. That's the That's the Fiddle Yard and Bentonville looking in from the area where the scrapyard was just shown. That area is about 14 feet long, and Bentonville's on the top. It has a munitions area, it has a fuel area, team track, and a couple of grain related industries at the far end. And there's trains underneath, and that whole town will tilt. It's hinged on the backside, so it can be tilted up to access the tracks underneath them in that area. Yeah, you can see the split there. And that's the lower tracks for the fill yard. I use NCE. Been using NCE since I think about '96. Good system. Next. Now the back, that's another shot. Bentonville above, fiddle yard below. We've seen that one before. Tracks in, okay, Summit. This is the left-hand side of Summit. Tracks came up from the left side and they go into town. What you see is a pulpwood loading area, and the buildings in the backdrop are a fruit processing plant. I've got a auto wrecking yard, and some of the buildings in the back, you're looking at, again, photographs, three-dimensional mixed in with the photograph. Green building is all photographs. The building, the wood building in front is three-dimensional, obviously. There you go. Good times massage parlors. Always an interesting place to be. Next. Rogers Gas, part of it's scratch build, part of it's DPM. The buildings in the back are, again, photographs of buildings, of model buildings. And I painted the tops of the trees in behind them. DPM building, Roger, not Roger Grebdig, Roger on my crew is an Irishman, so he wanted a gas company for some obvious reasons that I won't mention. Next. This was a Summit Tub and Shower. We just added to that building. The third story is actually a photograph of the building, and it's glued onto foam core and attached to the back of the building. It started out as a 1.5 story or 2-story building. When we reworked the area, I wanted a little more height out of it. So we photographed it, massaged it on Photoshop, and added a 3rd story. Next. This is sass and vinegar. Part of this was a fine, I think it might have been fine scale miniatures kit. I don't remember. I didn't build it, a friend of mine did. He also built the pickle works that are attached to it. And he also altered the back of the building to give the appearance of a new office being built. Next. The roof on that shed is aluminum, and he etched it and with I believe it's muriatic acid, something that's not too powerful, but it gives it a good weathered appearance and rustic appearance. Next. Pickle car is Atherin, obviously. In the pickle vats are caraway seeds, so it looks like the pickles are floating in the brine. Okay, I think we did it. I hope you guys enjoyed it. If there's any questions, fine. My email is there. I will be happy to answer questions if you have them later on via email. And so hopefully one of these days we'll all be able to get together and you guys can come out and actually have a look and see what it looks like there. Thanks for staying with me this long. And I'll hand it over back to Ryan, and take care.
All right. Thank you, Dick.
Thank you, Dick.
Very, very good.
You're
Thanks,
welcome. Take care, guys.
Excellent.
I think
All right,
that's it.
folks.
Did I? Oh, no, there, you did it.
All right. That was awesome. I'd like to introduce then our next speaker, our next presentation, and that'll be Tim Foote is going to do part 2 of his electronics. You ready, Tim?
I'm bringing it up here. Hold on. Can you hear me?
Yes.
Yep.
Okay.
Hear you and see you.
All right. This is your ultimate goal here, to develop a layout with one of these inside of it. I've got some interference here. Hold on a second. How do I get that thing out of my way? Well, gee. Do you see the full slide? You don't have anything interfering with it?
No interference. It looks good.
Okay, I have some in it, but I don't know I don't know how to get rid of it. Darn it. Whatever, I'll live without it. Okay. I decided to dive into digital command control to try to figure out what it was. And actually until just recently, it was kind of confusing for me. I called Duncan McRae, and he sort of straightened me out on some of the stuff. He was very helpful about it. Duncan owns Tam Valley, which sells all kinds of great electronic boards, etc., including the famous frog juicer. And he really knows his railroad electronics. So anyhow, I'm going to try to impart that knowledge to you. And you can get for those who are beginners and don't know much about DCC, you can get away without without knowing much. All you need to know is how to register an engine, and you can run your trains on DCC. But it is valuable to learn more about DCC, because sometimes you run into problems, and sometimes you want to tweak things on your decoders and that sort of thing. And so that's why I'm diving into this. Unlike a DC system, I've got all these people coming in, and I'm a host, I guess. Unlike a DCC, oh no, jeez. Ah, darn it. Okay, there we go. Did I get back? No. Previous. Sorry about that. Unlike a DCC system where lowering and raising power is used to control an engine, DCC uses pulses to control the engine. So DCC power is in the rails at all times. The DCC amplitude switches states thousands of times a second. The rails have only two states, on or off. For DCC coding, there is no concept of polarity, as only positive voltages can represent the on state. And I'll get into a little more detail in a minute that might sort of help you understand what all that means. The negative voltage is undefined as no voltage for purposes of DCC coding, that is. But there is negative voltage in a DCC system. I mean, you have to have negative voltage in order to get power to travel. Okay. And then in a DCC system, the DCC power is sent through the tracks to a decoder, which interprets code packets as instructions. A DCC command station creates the digital packet. Many command stations are integrated with an amplifier, a booster, this is what they're called, which in combination with its power supply modulates the voltage on the track to encode digital messages while providing electric power. More than one booster can be added to a layout to increase power to accommodate more track and more engines running at the same time. Cab control, which are also called throttle connections, can be added throughout the layout. You can set your layout up into separate power districts, each with its own breaker switch, which I highly recommend doing. Even if you just have one, even if you have a real small layout and you just call it one power district, I would recommend putting a breaker switch in between your power and your DCC control units. Even though usually there is an inner breaker switch on the units. This helps. It helps keeping, it helps from putting a lot of pressure on the units, which might wear something out. It's better to wear your individual breaker out than the one in the unit out. And this also helps, having power districts helps with troubleshooting, and as I said, provides added protection to your DCC components. Okay, now we're going to get into, if you have a strong cup of coffee right now, you might want to take a couple sips, because now we're getting into the real detailed stuff. DCC signals come in pulses. An AC power system has waves of power going from positive to negative, going up and down at a real fast rate. With DCC, they're actually pulses that look sort of like the diagram on the right. And you see the dot in the middle, that would be 0 volts, and then down below is negative and up above is positive. And the pulses are different widths, only they're just 2 different widths. And one width represents a 1 for a binary computer system, basically, which is like machine language in a computer. and then a wire width equals a 0. You'll be tested on all this when I get done. And the voltage in these pulses is power as well. That power totals usually anywhere from 10 to 18 volts. Okay, to represent a binary number 1, the time they're measured by time, and that's 58 milliseconds, and then a 0 is 100 milliseconds.
Microseconds.
I'm sorry. Oh, those microseconds? Okay, thanks.
You bet.
Okay. And these pulses are in bits. You know, I got that. I'm not taking the blame for that. I got that from DCC Wiki, which kind of drives me a little crazy the way they write things up. But anyhow, these, I won't take the blame for it. So anyhow, these pulses are bits which form bytes, and a few bytes form a packet. So you get a whole bunch of packets that are sent out to the decoder, and they can vary from 100 to 200 per second. So everything's happening very fast. And some of them I think repeat, but I won't get into that. Robin knows this stuff, who made the comment, knows this stuff a lot better than I do. Maybe someday we get him to talk about this. Function of a decoder in a DCC system. Each locomotive is equipped with a multifunction DCC decoder that takes the signals from the track, and after rectification, routes DC power to the electric motor as requested. And if you don't know what rectification is, I believe it's usually they use diodes to reverse the direction of the waves, of the electrical waves, and then convert the power into DC power. The DCC power is sort of similar to AC because it's going up and down. It's fluctuating back and forth. So that's how they are able to, with the diodes, they are able to convert into DC power. Your car's alternator has a rectifier on it to convert. It produces AC, alternating current, and it converts it to direct current, similar to what's being done in your decoder. Decoder is similar to a logic board. Each decoder is given a unique address for the layout and will not act on commands intended for a different decoder. So your controller can send out codes to various decoders, and there won't be any confusion. Each decoder is going to be able to fish out its own codes due to the basically the registration number of your decoder that you set up, which I mentioned in the beginning. That's all you need to know about this, really, is how to set up that registration number. Okay. Auxiliary decoder functions. The decoder can also route power to lights, smoke generators, and sound generators. These functions are operated remotely from the DCC controller. Stationary decoders can also receive commands from the controller in a similar way to allow control of turnouts, uncouplers, other operating accessories such as station announcements and lights. Polarity. DCC current is positive and negative pulses. The DCC wiring has to obey polarity for DCC to function and to avoid short circuits. Just similar to alternating current. You have current on one side, and then the other side, if those two sides connect, then you're going to have a short circuit. So you have to color code your wiring, make sure it's similar to DC. You have to make sure that there's no crossovers. DC engines on DCC. Note that DC motors can I've read some on the NMRA Facebook page. Every once in a while, somebody will bring up, can I use my DC engine on DCC? And the answer is, for many engines, is yes. But I think you're taking a risk, and I don't recommend it. And I think if you really want to run a DC engine on DCC, you should put out $20 and convert it to DCC by putting, because you can get a DCC decoder that doesn't have sound for $20 or less. There's something to do with harmonics and how the DCC affects the motor on the DC engine, and it can hurt it. Okay, this is a diagram of a TCS T1, very basic, non-sound. It's a wiring diagram, non-sound decoder, and all these colors, all these colored wires that come out of this decoder. This is all standard, these colors, and work on, I would think, almost every decoder there is out there. The NMRA has gotten involved in DCC, and they have set standards, communication standards, for the manufacturers, so that which has been very helpful, because that means and they've tried to get some consistency with these decoders, so that you can use no matter which DCC system you have, you can use almost all decoders from various manufacturers on your layout. You don't have to just get, like NCE makes decoders. They don't make sound decoders, but they make decoders, non-sound decoders. But that doesn't mean you have to use NCE decoders on your layout. You can use other brands of decoders as well. And a lot of that is thanks to the NMRA and their standardization of all this. The wiring for a basic non-sound decoder is standard and fairly straightforward. The red and black wires receive DCC power from the tracks. And as we've said before, that's converted to DC power in the decoder. And the orange and gray wires transmit the rectified DC power to the motor, which is isolated from the chassis. And the pulses that come out of DCC control the level of that power that's going out to the motor through the chip. It's pretty amazing what they've done here. This whole system was invented by Lenz, which is a German company, and they established with the NMRA and helped the NMRA standardize a lot of this stuff. Okay, the blue wire is a common positive DC current. That's for auxiliary items, and it's usually 12 volts for lighting. And the yellow and white wires are negative sides of the lighting circuits. White is a headlight and yellow is a rear light. Sound decoders can have wires for a speaker and a keeper capacitor, and usually two additional auxiliary functions. Okay, DCC configuration variables. Decoders have internal configuration variables, CVs they call them, that can be changed to alter functions. If you wire your lighting backwards, you don't need to rewire it. And you installed a decoder and your wiring was your lighting was backwards. Well, you can go and change that through a configuration variable. And the way you do that is, it's not really very hard to do. You probably get a manual when you buy your system, and it'll tell you how to input CVs. Also, the decoder manufacturers have a lot of literature that you can go online and download and get all the information about all the CVs on your particular decoder. Not all that stuff is standardized. It's up to the manufacturers how they want to set up. They often alter a lot of the codes. So beware of that. If you're going to dive into that stuff, you want to go get the PDF file for that particular decoder and and to make sure that, you know, you're not screwing everything up on the decoder. Keep Alive's, the two Soundtracks decoders on the right have a capacitor. A Keep Alive is a capacitor that will help retain the sound function during a short power interruption. There are higher power capacitors, keepers available that will retain the engine's power for a short period of time to get over switch frogs. And we saw Dick talking about his drawbridge there that leads to the door going outside of his train room. And I was thinking, I don't know if he uses keepers, but if you have a keeper on an engine and you shut that engine down, sometimes it'll keep going because of the power left in the capacitors. You have to always be aware of that. You also should make sure that your decoder is set up to accept a keeper. You should buy a special decoder that has the right wires coming out for your keeper, and do a little research if you're going to add a keeper to your engine. Runaway, oh yeah, there's the runaway engine things that I've already mentioned. Amp draw. If you're going to, the purpose for this is if you're going to convert, say, say an old Athearn blue box engine to DCC, which is a great exercise. I recommend that everybody do that. You have to first figure out if the engine in that blue box is good enough for DCC, because some of the old open frame engines draw just too much power, and too much power can burn out a DCC decoder. So this is a way to test that. What you do is you hold the engine down. This is a little gauge I made. The one on the left is volts, and the one on the right is an amp gauge to test power. And then I have that track, and this is all DC. You don't do this on DCC. There's no decoder involved here. There's no decoder in this engine that I'm holding down on the track. And basically, I also have a controller here, a DC controller, and you run the power up, and you push down on the wheels just for a moment, and you watch the amp meter to see how many amps it draws. And with an open frame motor, it often gets close to 1 amp, which is, you're kind of playing with fire there. You could burn out your decoder. And if it's a sound decoder, that could be $100 decoder that you've just burned out. So it's good to be aware of this amp test situation, and mostly just be aware that using old motors and DCC is probably not a good plan. You want to use a newer can motor, and the can motors are fairly inexpensive. What I did is I changed out an old Athearn and put a can motor. Ken Clark helped me with it, and it was very satisfying to watch what a difference the way the engine ran. Another thing you want to do if you're going to convert an old engine is you want to go through the trucks and the wheels and clean everything and re-lube everything, so it's running well on your DCC layout. And this is using a multimeter to diagnose problems on a layout. What I have it set there, I don't have it on the right. Oh yeah, no, I have it set on an ohm setting there, I guess. If you have a stretch of track or switch that's causing your engine to stall, you would first check it for power. And on a DCC system, even though AC really has nothing to do with DCC, you can use your AC setting on the meter to see if there's any power coming out of a piece of track that you have on your layout. And it won't hurt anything. You just make sure you set it. Don't set it, by all means, never set your multimeter on ohms when you, can somebody admit that person, please? Or is I'm the only one here can see them. Okay, thanks. Don't ever set your ohm setting when you have live power. Ohms produces, an ohm setting produces its own power. There's a little battery in your multimeter that sends out a small amount of power on an ohm setting. And that's all you need. You don't want any power in the system or you can burn out your multimeter. Don't ask me how I know that. So anyhow, you can use your multimeter to test to see if there's any power coming out of stretched track. And then if for a short circuit, you can try removing all the cars and engines from that from your power district or block if you're in DC. If the short goes away after removing the cars and engines, you can try replacing them one at a time to find the culprit car or engine. An ohms test sometimes will discover idiosyncrasies with turnouts in cars or engines where there might be shorting. The ohms test uses a small amount of electricity, as I mentioned. When using the ohms setting on the layout, make sure all power and layout is turned off. I've already mentioned that. Okay, for an ohms tracks test, remove all your engines and cars. The engines in some cars may have some crossover continuity through the wheels, which will affect the ohms test results. So keep that in mind. And on a car, that would only be, normally that would only be if you have lighting in that car. If you set up lighting in that car, then you'd have crossover continuity through the lighting that would register when you're trying to test across the wheels of the car for a short. Freight or passenger car service, you can test across the wheels where the reading should be infinite ohms, meaning there's full continuity. Do I have that right? Wait a minute. Unless there is a detector, where there's not full continuity, where there's no continuity. Unless there is a detector resistor circuit across the wheels or electrical pickups. Testing a track for continuity. Test across the tracks with power off. Test across the tracks to check for continuity. So if you test from one side of the track to the other side and you get continuity, something's wrong. You have a short somewhere. You can also check between the tracks of the same polarity to find an open circuit. So if you're not getting power somewhere, you can check from one track to another track. They should be connected and show no ohms. Those and then engine pickups, you can also check the continuity of pickups on an engine while it is off the track using ohms. Check between the wheels and each black or red pickup wire. And let's keep going. Soldering. Okay, now we're to soldering, and I'm almost done here actually. The key to successful soldering is the setup. Soldering, clean the surfaces. The black and yellow pen-like object on the right is a fiberglass brush for cleaning the area to be soldered. It really does an excellent job. The only drawback with the fiberglass brush is little pieces of fiberglass come off of it, and if you get them in your hands, on your hands, on your skin, you get a fiberglass itch, which I remember in my surfing days repairing surfboards. And that's no fun. So you want to vacuum after you clean an area, say on a piece of track, you want to vacuum it before you do any further work on it. Connecting the surfaces, the tweezers are soldering clamps. There's an aluminum soldering clamp below right here. And they all work pretty well. And they can hold the material to be soldered, such as a wire to a track. And they also act as a conductor of the heat generated, so you don't melt your ties, your plastic ties. This provides protection to other materials such as track ties. Clean up after soldering. The pick with a wooden handle is for scraping excess solder from the track, and that's one of my go-to tools. I use that all the time. Soldering flux is in the lower picture. is a type of flux paste, and you want to make sure you get flux for electronics. There's flux and solder for plumbing, and you do not want to use that stuff. It's got chemicals in it that'll just are a pain in the neck. You want to go to an electronics place and get your soldering stuff. You apply it to the area to be soldered with a brush. You apply the flux to the area just a little bit with a brush. I use a brush that I've cut to a little stub, and that works quite well. And though rosin core solder has flux in it, it helps to apply a small amount of flux besides that directly to the project as well. Only use flux meant for electrical applications. Okay, soldering tools. For model railroading, I use two types of soldering irons, a 35-watt and a 60-watt iron. Those numbers don't have to be exact, but close. The 60-watt iron has a cone tip, and I use it for soldering wire to the track and soldering track together. I lay the cone sort of sideways at an angle to get more contact when I'm soldering track. The 35-watt iron has a pointed tip, and I use it to solder wires, for example, when installing a decoder. Alternatively, you could purchase a variable powered soldering iron. I prefer having separate irons with separate tip types that are more portable. But if you want to get fancy, get yourself a variable one. You can just put an extension cord on it and stick it out on your layout and use it. It will work. I don't, some people probably swear by them. I don't know. In priming the tip, this is the key step in successful soldering, is priming the tip. On the right is a soldering iron tip metal scrubber. It's that gold looking metal thing you see there. That thing's a lifesaver. What you do, I'll go in a minute, we'll go through the soldering steps on that. I use two sizes of rosin core solder, as is shown here, a 0.32 diameter, real thin stuff for fine jobs like wires, and 62 0.062 inches for track soldering. And they're both rosin core solders. Okay, this is the process. The first step is to clean the area to be soldered. Solder won't adhere to corroded surfaces. The fiberglass scratch brush does an excellent job of cleaning the corrosion. And I also, sometimes if your wire is a little bit corroded, you might want to clean that as well. You can do it after you clamp it down. You can, rub the brush by a couple times after it's clamped down, as in the second picture there. Next, clamp the wire to the outside of the rail and brush the wire and rail with a small amount of flux. Heat up your soldering iron. If it's new, you should prime the tip with some solder. But actually, you should do that every time you solder. If it's been used, there will be soot on the tip, which needs to be cleaned. You push. All you do is very simple. You just push the heated tip into the scrubber brush that I have there, like in the picture, and twist the soldering iron back and forth. It'll look shiny when you pull it out of the scrubber. You do that for every time you're going to solder something. That isn't like something you do once a day. You do that every time you're going to solder something. You want to, as in the picture on the lower left, you want a shiny solder tip, like as it is. That's a prime tip it has some solder on it. I then heat the wire and the track by pressing the side of the soldering iron along them together. Then I touch the solder to the wire and track without contacting the tip. If you just contact the tip, the solder will oftentimes it'll just melt off and it won't attach to the track. The track has to be heated up enough to accept the solder. So that's why you just put it on the track and the wire at the same time. In a few seconds, the solder will melt and flow around the wire. Then quickly pull the iron and the solder away from the wire track to avoid melting your ties. Your next, if you go through this process and the solder isn't melting very quickly, you probably don't have a powerful enough soldering iron. That's why I use a 60-watt soldering. Or if it's dirty and you haven't primed it properly, you might have that problem as well. Okay, then your next step is to scrape away any excess solder that gets on top of the track while the solder is soft. If it hardens, you may need to use a jeweler's file to clean off the solder. It's not the end of the world. If the solder doesn't adhere to the wire and track properly, as I mentioned, it might not be powerful enough. The process is similar for soldering track together. Is similar for soldering track together and for wire to wire. For small wire, you may have enough solder on the prime tip. You might not even have to apply, if you're doing small wire like decoder wire, you're trying to solder things together. You may only have to just prime the tip with some solder and not even add solder when you're soldering the wire together. Use shrink tubing on a wire connection to cover any bare wire to the wire-to-wire connections. You shrink the tubing with a heat gun, and that's a box of shrink tubing on the right there.
Hey, Tim?
Yeah.
A question on that slide you just had.
Here, let me go back to it. Okay, is it Paul?
Yeah, hi.
Hi.
I see you using those clamps to hold the wire against the rail. Is that a specialty tweezers that you bought somewhere?
Yeah.
For that purpose? So you look for that. I mean, you look for that kind of thing, and the tips hold together automatically.
Yeah, it's. I'd have to go way back to get. There was. I think I had that whole thing. Yeah, they have spring to them.
Yeah. Okay.
They hold together. Yeah.
So they hold that for you, and you don't have to. That way, it frees up your two hands. But those are things you can find somewhere like Micromark or wherever.
Yeah, you can find those online. I found a bunch of them. There's a guy at the swap meet that at the, not the train swap meet, at the regular swap meets, that has all these, tools, including like doctor's tools and stuff, dentist tools, and they sold those as well.
Now the other thing,
if you can find one of those guys at a swap meet, that's a great way to find that stuff.
Yeah, I've seen those guys. Now, the second thing, are you going to go into wiring, soldering wire together? Because I have a question about joining the small, especially small wire like on the DCC component.
I'm not going to do it anymore, but just give me, what's your question?
So in order to solder two pieces of wire together, there's something I think they call a butt joint. And you're supposed to have the two wires together. You're supposed to interleave the strands, and you're supposed to give it a twist. I mean, that's impossible to me to do. And so what I end up doing is I hold the wires together so the tips stick out, and I twist them together, and then I solder that, and I cover it with the shrink tubing. Do you have is there a trick to do butt joints on tiny little wires, or what do you think about that?
I think the way you're doing it is just makes much more sense. If those wires are clean, and then I would put a little dab of flux, on the wires twisted together.
Yeah.
If those wires are clean and they're twisted together, and you get some solder to stick in there, it's never going to come apart. That's plenty. You don't have to do that.
Yeah,
that other thing sounds crazy to me.
Yeah, like I said, I've given up on butt joints. I've seen on the internet they're preferable, but I don't see how people do it because my fingers are too big to even hold the wires, and then that's two hands. I don't get it, but the solder flows pretty nicely using the flux, so I have a little trouble with that. But
Okay. Are the guys that recommend these braided joints, are those rivet counters?
It's probably more like they're larger diameter wires. I'm looking at sites where they're talking about, cars, electronics or something like that.
Oh, okay.
But I don't know. I've just seen a lot of recommendations. Butt joints are better, but I just never understood how you do it.
There's guys that don't get sleep worrying about little things like that. Okay. And then Rudy, I have to give Rudy credit on this. He brought up, how do you remove solder? And the best way to remove solder is never put too much on. And then you don't have to worry about removing it. But you might come into a situation where you need to remove it. And there's a couple different systems. Some use these little bulbs and suction and that kind of stuff. And I've never tried that. It probably works well. A very simple way is this braided wire. It's a solder wick. You can get it online or at an electronics store, that sort of thing. And you just lay that. You heat up your iron. Let's see if I got it there. Yeah, you lay the braid on top of the solder and place the heated soldering iron on top of the wick, and then you can lift the wick up and see how much you pulled off. If you haven't pulled off enough, move down the wick a little bit to a fresh spot and put it back down and redo that until you get the solder up. And then notice the thermal shunt. That would be a metal clip there to absorb some of the heat for that process. Okay, and that's it. Any more questions?
Thank you, Tim.
Do I come out of this or do you pull me out of this?
You go poof.
Poof. It's not working.
Oh, the presentation?
Yeah.
There you go.
Okay. Oh, I forgot the test.